Hi, I am Dr. Samir Ben Osman, and in this video we're going to talk about the principles of climatology, which is the study of the atmosphere and weather patterns over time on planet Earth and other planets, but we're going to focus on planet Earth here. So the atmosphere, which means the sphere of air, is a protective layer of gases. That's the thin blue line here, actually, that enables life on Earth by keeping temperatures within relatively small range and blocking out harmful solar and cosmic radiations. In this image, you can see, how thin the atmosphere is, and actually the orange sphere that surrounds it is not the atmosphere, but that's actually the ionosphere. And the atmosphere is protected by Earth's powerful magnetic core, which envelops the atmosphere and extends far beyond it, which is called the magnetosphere. Earth's atmosphere is mostly composed of gases that do not interact with the solar photons, the solar radiation. So that's 78% nitrogen and 20% oxygen. However, it also contains gases that trap solar radiation, and they're called greenhouse gases, such as carbon dioxide, methane, nitrous oxide, and ozone. Their scarce presence, which is 0.1% of the atmosphere, is actually essential to trapping just enough energy to enable life on Earth without overheating it. Oceans and forests also regulate atmospheric heat, but on longer timescales. So as, quote unquote, gravity hugs the atmosphere to the Earth's surface, heavier gases and elements are pulled closer to the surface, while lighter gases, remain farther away. Since greenhouse gases have varying masses, some of them heavy, some of them light, the air temperature increases and decreases with altitude depending on whether greenhouses are present or absent in that altitude. And so that gives actually rise to four main layers of the atmosphere. So we can start from the lowest to the highest with the troposphere. Troposphere means the sphere of change and the sphere of basically life. And that's where the average temperature decreases with altitude. And it contains about 75% of the mass of the entire atmosphere. And therefore, this is where all the weather occurs. And this is where airplanes fly. They fly at the top level of the troposphere. And the base of this layer is warmer than its top because the air is actually heated by the surface of the Earth, which absorbs the sun's energy. Now above that we have the stratosphere, which is the layered sphere, basically, and where the temperature increases with altitude. So yes, the higher you go, the warmer it gets. And temperatures do increase in the stratosphere because of increasing amounts of ozone, which, like we said, is a greenhouse gas. And especially it absorbs harmful ultraviolet rays of sunlight. And by absorbing them, it transforms them into heat, into kinetic energy, molecular kinetic energy, which is heat. And that's why we have more heating. Above that, we have the mesosphere, which is the middle sphere, where the temperature decreases with altitude again. And the air density is very thin, but still thick enough to burn up those falling meteors, creating what we call shooting stars. Above the mesosphere, we have the thermosphere, which is the heat sphere. Why is it called the heat sphere? Is because the temperature increases again with altitude. And it can reach actually over 2000 degrees Celsius upon high solar activity. However, the air density is so low that the temperature is very sensitive to solar activity, and it can heat up into a plasma. The plasma is basically the state of matter where the electrons get a little bit separated from the nucleus of the atoms, and that creates ionized gases. And so those plasma is going to interact with the Earth's magnetic field to form the aurorae, as you can see here. Also, astronauts that orbit the Earth in the International Space Station, they reside in the upper part of this layer. Sometimes people call it the exosphere, but most of the people make it part of the thermosphere. Now, it's important to note that although the temperature, yeah, can reach almost 2000 degrees Celsius, but that's not what you're going to feel in the air, because the air is so not dense. So like the particle of gas will be heated, but there will be a lot of space between particles of air. And so let's focus then on the troposphere, because that's where the weather happens. Let's see how the climate happens and what affects the climate. So the climate patterns are generated by two main factors: the rotation of the Earth and its position relative to the Sun, including its latitude, the air pressure variations, etc., as well as the rotation of the Moon around the Earth. And so basically all the weather components will stem from these two factors. So let's take them kind of one at a time. So let's take the position relative to the Sun. So because of the Earth's rotation's axis is tilted, the tilt towards or away from the Sun over the course of the year determines the amount of heat that the part of the planet will receive. And as such, when the hemisphere is tilted towards the Sun, as you can see here in the south part, it's going to receive more solar radiation per area, and thus experiences summer. So like the same area will receive more solar photons, while the opposite hemisphere, as you can see here, is receiving less solar photons by surface area, and thus will experience winter. This uneven heating also has another effect, which is to produce global air circulation patterns from hot to cold, as well as global water circulation patterns in the oceans. In addition to that, the axis of rotation of the Earth, let's say, wobbles, which is called an oscillation, across tens of thousands of years. So it does a full circle every about 26,000 years, which prompts long-term climate events such as ice ages and global warmings. Now, in addition to that, the latitude variations impact the weather, because at the equator, the weather is usually hot and humid all year round, because it always receives roughly the same amount of sunlight throughout the year. However, the farther away we go from the equator, the more pronounced the variations in sunlight exposure, and therefore the temperatures tend to cool gradually the further away we get from the equator, because they receive less sun rays per area. Now, in addition to these variations, we will have variations in the masses of air and the masses of water that go inside them. So how does this happen? So as the sun heats the air molecules, which gives them more movement, i.e. more space, and so they will take less density, i.e. they will have less pressure. So more movement, they will take more space, they will become less dense, they will have low pressure. And so they will rise, creating what we call vertical currents, as you can see here. Now, air pressure is influenced by differences between hotter and cooler pockets of air called fronts. When fronts are very different in temperature, they will try to mix together to reach equilibrium. Again, the principle of trying to reach equilibrium. And so by trying to mix together, they will create movement and pressure. And as the air attempts to equalize by moving from high to low pressure, it generates what we call wind. Now, let's see what happens at low pressure and then high pressure. So at low pressure, warm air molecules that move faster, like we said, they will create more space between them. And so that space is going to allow water vapor molecules to put themselves in the middle. And so warmer air has more humidity, or has more capacity to contain humidity. Also, warm air rises, and so it's going to take the moisture with it until it goes to a certain altitude where it condenses and forms clouds. When clouds are saturated with moisture, they will produce precipitation in the form of rain or snow, and that's according to the air temperature, as well as the presence of dust particles that will kind of stick to rain droplets and snow droplets and make them fall. So more space also means low pressure, and therefore the lower the pressure, the cloudier the weather and the stormier the weather. Now, by opposition, high pressure areas air molecules are packed more tightly together and thus have less space to hold water vapor. Therefore, the higher the pressure, the clearer the sky. Now, in addition to these effects, there's a third effect that's going to influence the movement of air and clouds, and that's called the Coriolis effect. So what's that? As the Earth rotates, and while warm air masses are rising, as you can see on the left-hand side, instead of going straight up, because of the circular motion of the Earth, they become circular. And that's what's called the Coriolis effect. And this effect runs clockwise, as you can see here, in the northern hemisphere, and anti-clockwise in the southern hemisphere, and gives rise to a large circulating weather systems that can form cyclonic systems such as hurricanes. Now, evaporation from bodies of water is going to add moisture to the atmosphere, causing cloud formation in low pressure areas. It also makes coastal regions more humid than deserts. Additionally, large bodies of water have higher thermal storage capacity than land, and thus create temperature differentials between land and water, sending what we call breezes inland during the day and out to sea or to the lakes at night. So now that we saw the effects of the Earth rotation around the sun, what will be the effects of the moon rotation around the Earth? So that's going to affect the bodies of water that are in and around the Earth. So the moon's gravity is going to pull those bodies of water in a continuous circular motion, as you can see here in those animations. And that's going to create what we call tides, which will affect the weather through the amount of warm or cool water that's moving throughout a given area, and also help fertilize, because move the nutrients around on Earth and fertilize the Earth. So you see how important the moon's gravity and the distance at which it is, specifically, and its mass, is to enable the temperate climate and the fertilized land in which we live. And with that, we came to the conclusion of this video. I appreciate your comments. Thank you for your attention, and I'll see you in the next video.